Welcome to Kaiju Mathematics. Today I will be looking at the scenarios of pulling two cards with and without replacement. The differences between with and without replacement is 3 letters. And those 3 letters change everything about this experiment. The word with means I am taking a card out, I'm observing that card, and then I'm putting that card back into the deck. So the word with makes these two events independent of one another, meaning that they don't affect the next experiment, the next event happening. The previous outcome does not affect the next. The word without replacement means I am taking the card out of the deck, I'm observing it, and I'm putting it off to the side. So then the next card I grab, its probability of me grabbing that card is affected by that previous grab. So these events are dependent. So with is independent, and without replacement is dependent. So I'm going to do an example here with replacement. Let's say we're pulling 2 cards, and I want the probability of pulling a 6, and then I want to pull another 6 with replacement. So 2 6s. So let's just say probability of pulling 2 6s. Let's fix that up a little bit. Just say 2 6s with replacement. So on the first grab, I want to pull a 6 out of the deck. There are 4 6s in the deck out of 52. I'm observing the card, putting it back into the deck. And since these are independent events, we just consider it the word and with the word and we have multiplication. So we want to multiply the probability of pulling a 6 times the probability of pulling a 6, and it's just 4 out of 52 again, because I put that 6 back into the deck, so I'm not changing the number of 6s in the deck, and I still have 52 cards in the deck. So here we're going to have 4 out of 52 times 4 out of 52, which is going to be 0.0059. Let's now do the same thing. 2 cards. And we want to pull 2 6s without replacement this time. Without replacement. So I'm not putting that card back into the deck. So I want the probability of a 6, which is 4 out of 52. And I want to multiply that by the probability of pulling a 6 given the first card was a 6. So I want to pull another 6 given the first card was a 6. So if the first card was a 6 and I didn't put that card back in, that means I now have 3 6s out of 51 total cards. So let me rewrite this out. So 4 out of 52, probability of pulling a 6, times the probability of pulling another 6, given the first card was a 6. So we're down to 3 6s out of 51 total cards. 4 out of 52 times 3 out of 51 is going to be 0.0045. And as you can see, those 3 letters changed everything about this problem. 3 letters without replacement. I'm not putting that card back into the deck, so my probabilities change. It's conditional. These events are dependent now. Where with independence, the previous outcomes are not affected to the next event, so we could just multiply those probabilities together, and we don't have to really worry about it, but with dependence, we do. I hope this helps, and if you like this content and you need more math and calculadocos in your life, please hit that subscribe button, and thank you so much for watching.